All right, you had number 1 to 5 on your sheet last night. So number 1 says a freight train with a mass of 6.8 times 10 to the 5th kilograms. So 6.8 times 10 to the 5th kgs is moving down a track 0.5 meters per second east. So V is 0.5 meters per second going east. What is the momentum of the train? So it's just looking for P, not delta P, not the change in, just the momentum. So P is equal to mv, so 6.8 times 10 to the 5th kilograms times 0.5 meters per second should give you a momentum of 3.4 times 10, was it 5 or 6? I can't even see. I think that's a 6, even though I said fifth. 6 kilogram meters per second, and the momentum is always in the same direction as the velocity. So part A will be east. Part B says what impulse would have to be put on the train to stop it? So for part B, impulse is J, and J is equal to the change in momentum, which means it's equal to the mass times the change in velocity, or the mass times Vf minus Vi. And it says to stop it. So Vf, this now becomes my Vi, and Vf is 0. And so the impulse J will be equal to the 6.8 times 10 to the 6th kilograms times 0 meters per second minus 0.5 meters per second. And so you get a J of negative 3.4 times 10 to the 6th kilograms, where the negative means west, because the impulse has to be in the opposite direction of the motion. Otherwise, it won't stop it. It'll speed it up. Number 2 says, how long must an unbalanced force, so F is 500 newtons, how long must an unbalanced force act on a 1,500 kilogram car in order to increase its speed from 5 meters per second Vi to 15 meters per second Vf. Okay, so if you think of your equation, you're looking for delta T, so you know F delta T equals M delta V. Divide both sides by F. So M, and remember delta V is just Vf minus Vi divided by the force. So 1,500 kilograms times 15 meters per second minus 5 meters per second divided by 500 newtons. 500 goes into 1,500 3 times, and 15 minus 5 is 10. 10 times 3 is 30 seconds. Okay, number 3 says a ball that has a mass of 0.2345 kilograms is moving at a velocity of 15 meters per second. So Vi is 15 meters per second. When it is hit by a bat, causing it to move in the opposite direction of 30 meters per second. So this one is towards you, and this one is away. So you're going to have to look after your directions here at some point, okay? Find the force if the bat hits the ball for 0.01 of a second. So we're going to use exactly the same equation that we did in number 2. This time we're going to solve for F. So F delta T is equal to M delta V. So F is equal to M Vf minus Vi over delta T. So the M is 0.2345 kilograms. The Vf, now you got to figure out which way do you want to call positive. So I might call towards me positive, so then my away goes in as negative 30 minus, and the towards goes in as positive, so 15. And then the time is 0.01 of a second. So in the brackets, I end up getting negative 45. I'm going to multiply that by my mass and divide by 0.01. And when I do, I get 1,055 newtons. And it works out to be negative. And this negative is what I called away. I think on the question sheet I called forward, like going back to the picture. Okay, so towards you and away from you, or however you want to call it, but it definitely means it's going back to the picture. Okay? Number 4. A car of mass 1,400 kilograms crashes into a solid wall and is stopped. VF is 0. In 0.05, t is 0.05 of a second. If the car was traveling VI 5 meters per second north, when it hit the wall, what is the force? All right, so again, F delta T is equal to M delta V. So F is equal to M VF minus VI over delta T. M is 1,400 kilograms. VF is 0. VI is, 5 meters per second. And I'm calling north positive. And delta T is 0.05 seconds. And solve for your F, and you should get 1.4 times 10 to the 5, maybe? Not doing it on my calculator, I'm doing it in my head. I think it's 5. Times 10 to the 5 meters per second, right? Because it's going to move the decimal 2 places. 1, 2, yeah. All right, and it works out to be a negative. And that negative means opposite motion. Which they told us was motion was north, so that negative means south. So that was the question, what is the force that the wall puts on the car, right? To stop it, it has to put a force opposite the direction of motion. B says, what is the force that the car puts on the wall? Well, it has to be equal and opposite. That's Newton's third law. So you don't have to do any calculations. You just have to know that the car must put an equal and opposite force back on the wall. So 1.4 times 10 to the 5th force newtons south. Okay? And then part C, what is the impulse that the car experiences? So J equals M delta V, or M VF minus VI. So J equals 1.4 times 10 to the, no, it was to the third, sorry, kilograms. Just for a second, I thought I was writing it down wrong when I started with the 1,400. 0 meters per second minus 5 meters per second. And you get a J of negative 7,000 kilogram meters per second, or Newton seconds, and the negative again means south. Okay, last question, number 6.